Hey everybody, how's it going? Welcome back to Computer Science 4300 C++ game programming. The stream started there with the wrong title. I teach two courses. I had the wrong, I had 3200 up there, but I assure you this is 4300. All right, so today we finally get to start programming. After all like 3 lectures of hearing me talk about C++ and watching me programming, now you all get to do some programming, so that's pretty awesome. I am going to talk today about assignment 1, but first I'm going to show you how to set up the environment that you're going to be programming in. That is very, very easy to do if you're using Linux or Mac, but it's a little bit more complicated if you're using Windows. Even though Microsoft has taken great steps to like increase the usability of Windows as a development environment, we're going to be using, it still requires a few steps. So we're going to be using Visual Studio, and I'll get into that. So what I've done is, because I didn't really want to alter my, my machine in order to show you how to install stuff. So what I have is I actually have a virtual machine set up. And if I can, okay, so that's working, awesome. So this is like not a completely fresh machine, but it's fresh enough so that we're gonna have to do some stuff to get the assignment working. So rather than just give you these instructions and leave you on your own, whenever I'm setting up a new thing, the first thing I always do is go to YouTube and I say, how to install this. Or like one of the best things I ever saw on YouTube was a tutorial video on like how to install Node and how to use Node. And that was like, it was so good to watch a video of someone doing it, because there were a lot of different files you had to put in different places and stuff. And this is going to be sort of the same way. So I'm going to go through it with you, and we will do that together. So first of all, there are some tutorials up here and some information. So we are going to be using the SFML library, the Simple Fast Multimedia Library, and that is going to do all of the drawing for us. And of course, we're going to need to be able to download that. And so here's the URL for downloading that. There are some excellent tutorials on SFML that I'll go into a little bit later. And there are some Mac instructions here, but just keep in mind, I have Mac instructions here that will probably be easier. And I've tested them, and they worked on someone else's laptop, but unfortunately, I can't show you video of a Mac machine because I can't swap between machines while I'm doing the stream. But I can assure you that the instructions have worked for me, and if someone out there is using a Mac and can follow these instructions and tell me if they worked for you on the Discord, someone in the class, please do so, because that would be great if they work. So first I'm going to go over the Linux instructions, then the Mac instructions, and then the Windows instructions. However, I'm only going to handhold you through the Windows instructions, because the Mac or the Mac and Linux instructions are literally just typing a few commands. And so there's no reason for me to just type a few commands and show you that and like have a completely different virtual machine and stuff. So let's just get started. Linux instructions. So there's just a few things that you have to do here to get everything up and running. So the first thing you need to do is you need to install GCC, that's the GNU-C compiler, and that will install the C++ compiler that we're using for Linux or Mac for the course. And you also need to install SFML. If you are using Ubuntu or any other Debian-based Linux system, then you can do all of that with a single command. Okay, so you say sudo apt-get install. If you're using Linux, you're very familiar with that command. You're going to install G++, that's the compiler, build essential, that's the C libraries that the compiler needs to run, and then libsfml-dev. So if you're in Linux, you can copy and paste this command into your terminal, and that will install everything that you need for the course. It's pretty awesome. Oh, build essential also installs make, I believe, which we'll be using in later assignments. Then you're going to download and extract the zip file for the assignment. And I've asked on D2L, students have gotten emails with the individual download links to those assignments, okay? So you go, if clicking on the link doesn't work, you're going to copy the link, paste it into a new window, and that does work. That's not a function of the link, that's a function of the student email system at the university. So please just copy and paste that link into a new window and it should work fine for you. Once you've extracted the zip file, all you got to do is you navigate to the assignment root directory, meaning wherever you extracted it to, and then you're going to use G++ to compile the program with the following command, okay? So you're just going to copy and paste this command into the terminal and it will compile for you, okay? But you just have to remember that you have to be in the folder, you have to change directory to the folder where you extracted the zip file, and then this command will work. So what is this command? This command says use G++, okay, so compile, all the CPP files in the assignment, include the source directory, use the standard of C++ 17 that we're using in this course, and then place the resulting executable in the bin folder as SFML game. That's the name of the executable. And then link all of the SFML libraries that we're going to be using for SFML. In future assignments, you'll be able to do that by just typing make. But for the first assignment, I want you to type the actual command to compile it, because for the first assignment, there's just a single CPP file. And so we don't need to go overboard with a make file just for the first assignment. But for future assignments, there will be a make file, and that make file will work on both Linux and Mac. So instead of typing this on assignment 2, 3, 4, you can just type make, okay? So that will place the executable SFML game into the bin folder. And then in order to run it, you can change directory into the bin folder and then run the program by saying /SFML game, okay? So what you'll find very quickly is that it's going to get kind of annoying to have to compile it, change directory into bin, and then run it. So what I would recommend for you to do is just write a little bash script or something that does that for you, okay? Now, in the future, in the make file, you'll be able to just type make run from one directory and it will compile and run it for you. But just for the first assignment, I kind of want to get you Linux people used to, okay, here's the compiler command and getting used to looking at that and what it looks like. And then, okay, now we have a bin directory where our thing goes, and then we have to move there and then run it. The reason we have to change directory into the bin folder is because there's a config file in the bin folder, and that is read locally. So the program that we run assumes that the current working directory is the bin folder, and it loads that config file. All right, so that should just work. I've tested that a dozen times, and it does work. So if it doesn't work for you, just go to the Discord into the 4300 general channel and say what's not working, and I'll be happy to answer the questions there for you. All right, now for the Mac instructions, I have tested these twice, and they do work. I have not tested it on like the Mac M2 architecture. I have tested it on the M1 architecture though, and it did work. So hopefully it still works. All right, and I've tested it on an older version as well. Geez, excuse me. So you're going to use brew. You may need to install brew. I apologize, I don't have the instructions for installing brew on a Mac, but you have to install brew. It's kind of like a package manager. And then you type brew install SFML, and then you follow the Linux instructions. Okay? So following the Linux instructions from there will work on a Mac, because Mac has, you know, really nice Unix terminal. And that's it. That should work. Then you should be able to follow the same instructions, use the same command, and that'll work for you. So this worked. When I did it, I actually tried Clang. It should work with G++ as well, but that should work on a Mac. Please, please, if you're using a Mac and you're watching this, try it right away and then post on Discord if it worked. I really want to know if it worked for you on a Mac. If not, I'm going to have to change these instructions. If you decide to use Xcode, now, the Mac instructions that I linked up here, that uses Xcode, and it's a bit more complicated. If you decide to use Xcode, you're on your own, okay? I cannot help you set up Xcode because I do not use a Mac. I am not familiar with Xcode, and these instructions should work, okay? Now, the last thing I will say about the Linux and the Mac instructions is that once you've got the ability to compile your program, you can use whatever text editor you want, okay? You can use VS Code if you want to. You can use Notepad if you want to. It doesn't really matter because the compiler is doing all the work for you. So whatever you feel comfortable with editing the CPP and .h files, you can feel free to do that. I would recommend for Linux and Mac using VS Code. It's a nice editor. All right. Now to the Windows instructions. So these are a little bit more complicated, and there's a reason that they're more complicated. But in the end, after the more complicated setup, the Windows users will have the nicest time in the course because we're going to be using Visual Studio. So the first thing that you're going to do is you're going to download and install Visual Studio 2022. That's the only thing that I've done on this machine. I have already installed Visual Studio 2022. I installed the Community Edition because the Community Edition is free. The only thing you will have to do is that if you don't have one already, you'll have to create a Microsoft account and sign in with your Microsoft account. But it's completely free. The only thing you have to watch out for is you have to ensure that when you run the Visual Studio 2022 installer, that you click Desktop Development with C++. That will install the C++ compiler, okay? Someone out there asked, I'm currently using Visual Studio 2019. Would there be any differences between this version and the 2022 version that could cause complications? That's a very good question. Up until a few days ago, I was also using 2019. I'm not sure if it's going to cause complications for you. I know that, for example, if I had released a Visual Studio 2019 project, you could open in 2022, but I'm not sure, like right now, the project file that I'm releasing is a 2022 project file. So if you install 2022, you can have both 19 and 22 operating at the same time on your system. That's completely fine. But when you go to open the file, when you go to open the solution file, just right-click, open with, and choose 2022, okay? So I am not providing any support if you continue to use 2019, so please use 2022. And just keep in mind, again, this is the 5th or 6th time I've mentioned this in this course, Visual Studio, okay, Visual Studio 2022 is not Visual Studio Code, is not VS Code, okay? VS Code is a glorified text editor, okay? It's got a lot of room for plugins, and so you could turn it into something that looks like an IDE, but it does not contain a compiler. Visual Studio does contain a compiler. They're just unfortunately named very similarly. Okay, so over here, I have another window, and so you're just going to Google Visual Studio 2022, and you're going to download it. So you're going to click download, you're going to click community, it'll download an installer, and you run that. It took me about 20 minutes for that to download and install. So I'm not doing that here, but that is all that I have done, okay, in terms of setup. Alrighty, I got a question. Has the assignment been released yet? Can't seem to access it. No, so the assignment has not been released yet. It's going to be released around an hour after the lecture is finished. Because what I like to do is I'm going to go through the assignment with you, and if I find any errors by going through the assignment with you, I want to have the ability to fix those errors before I release the assignment. So it will be released within about an hour of the lecture finishing. Alrighty. So that was step 1, install Visual Studio 2022. If you already have another version installed, please install this version. You can have both installed at the same time. All right. Oops. These are old instructions. I'm going to fix this. This is why I do this. But this should be... Oh, I think yeah, okay. I just needed to refresh this. So we are using the 64-bit version of SFML. All right. So the 64-bit version of SFML is available here. You can directly copy and paste this link, or you can go to the download page, which I have open over here. And here, this is the one that we want. Okay, I apologize. I had an older version of this file cached, and I had to refresh it in order to say this. But it is the 64-bit version of SFML that we're going to be using. So over here, you'd click download, you'd save this zip file. I already have that done, so I'm not going to re-download it. The next step is to extract SFML to a folder on your computer with no spaces in it, okay? Unfortunately, because we're going to be using Windows environment files, they do not like folders with no spaces. So we're going to show you my recommended place to download and install this. So I highly recommend creating a folder in your C drive called libraries and then extracting it there. So for example, if we do that, which I'm going to do right now, we're going to have C libraries SFML-2.5.1. So that's going to be the directory where we're going to install this. So let's just go and do that. So I have SFML already downloaded. So I have a folder here, COMP4300. I have downloaded the 64-bit version of SFML. So I'm just going to open that. I'm using WinRAR. You can use whatever you want. And of course, I have not registered WinRAR. So all we have to do is take this, drag it over into our C libraries directory. And there you go. The library is extracted and installed. Okay. So the remaining steps will be telling Visual Studio where those libraries are, but that's basically it. So over here, we've got SFML-2.5.1. We've got a bin directory. The bin directory is going to contain all of the DLL files, the dynamically linked libraries, that Windows is going to use in order to let us run our programs. So these are the runtime libraries for SFML. We've got some docs. We're not going to go into that. We've got some examples, so you could go look at the example code if you want to. We've got the include directory. The include directory is where all the header files are that we're going to be using for SFML. And the lib directory, that is where all the lib files are, which are precompiled libraries that we are going to link in our program. And so I know that sounds really complicated, but I've set it up to be really, really easy to set up and use this. So all we did there was we extracted the 64-bit version of SFML into a folder with no spaces in it, and I recommend having a libraries folder, and then inside the libraries folder, you have SFML. Certain versions of Windows, you may have to like do that as admin or something because it doesn't like you doing things directly to the C drive, but put it wherever you can. It doesn't really matter as long as there are no spaces in the directory name. Okay, let's go back to our directions. So now what we're going to do is we are going to create a Windows environment variable. And Windows environment variables are sort of like, it's a config file for Windows that points to a bunch of different stuff, okay? And what's going to happen is our Visual Studio project file is going to read this environment variable to say where SFML is. And all of your future assignment project files are going to use that same variable. And so these instructions are a one-time thing. So for every subsequent assignment, you're just going to be able to download the assignment, double-click the solution file, and it'll work. This is all one-time installation instructions. All right, so let's follow those instructions. So in order to create a Windows environment variable, you're going to click the Start menu, and then you're going to type env. And so you're either going to edit variables for your account or for the system. It doesn't really matter. Let's just say edit environment variables for your account. If you edit for the system, then what that does is it creates these environment variables for every user on your computer. So let's just edit them for our account. So this window pops up now. I'm going to minimize this other one. And here's what we're going to do. We're going to click New. So let's click New. So we're going to click a new environment variable. We're going to call this SFML_dir. And then we are going to browse for that directory, or I don't need to browse because I've just got it right here. This is where I installed that. So I'm going to click here and then click OK. So I've clicked OK. Now we have a variable called SFML_dir that programs can read and tell us where SFML is actually installed. Okay. This will not work if the variable has any spaces in it. So if this has any spaces in it, it may not work, okay? If you had Visual Studio open, you need to restart it now, all right? So if you had Visual Studio open, you need to restart it now. That's because when Visual Studio is launched, that's when it reads in these environment variables. Okie doke. So now what do we need to do? We need to download and extract the assignment zip file from the link sent to you via email. Okay, I had a couple of questions. Is it possible to have an assignment for public? Nope. There are no files being released to the public. I apologize. You can follow along with the lectures, but I'm not releasing the assignment. Someone said, what is the difference between SFML and OpenGL? OpenGL is a very low-level programming language where you have to do everything manually. SFML is built on top of OpenGL and provides us with really nice functionality so that we don't have to beat our heads against the wall for the rest of the term. All right, back to the instructions. Download the assignment zip file. Okay, let's do that. We're going to close this for now. So over here, I have the assignment zip file already downloaded. So I'm going to right-click and then extract to some folder. So I'm going to extract it to the folder with the same name as the zip file, and I have this open. So let me very quickly explain the structure of the assignment here. So there are 3 folders and then 2 files. The bin folder is where you are going to have a, that's where the executable is going to be placed, and all the binary files associated, and the binary files and config files associated with your project are going to go into the bin directory. I've also included a solution so you can see what the solution looks like, a config file, etc., but I'm going to go into those details a little bit later. We've also got a source directory. This is where all the source files for the project go. And this is, right now, for the assignment 1, it's only 1 CPP file, but for future assignments, there will be many more files. Then we have a Visual Studio directory, and that's where all the Visual Studio project files go. And down here, we have a marking scheme that you can read, and then a README file, which explains the assignment, but I'll do that after I finish with the instructions. So what do the instructions say? Let's go back. Download and extract the assignment zip file, then navigate to the Visual Studio folder. Okay, so we're going to go into the Visual Studio folder. Now we're going to double-click sfmlgame.sln Visual Studio solution file, and Visual Studio should launch. Okay, so what I'm going to do, just to be a little bit more explicit, is instead of just double-clicking, I'm going to right-click, open with Visual Studio 2022. So you see here that I have Visual Studio 2019 installed as well. And so I'm just going to make sure that I'm opening this with Visual Studio 2022. So this is a virtual machine. It's going to take a little bit longer than on my native machine. So here we go. So we have opened up the project file. It's still loading. The first time that you run Visual Studio 2022, it might take 2 or 3 minutes just because it has to do some stuff before it launches for the first time, but it is gonna load, right? It might take a little bit longer than this. All right, here we go. So I now have, this is Visual Studio. Over here, I have it set up so my Solution Explorer is on the left. We can see that I have main.cpp. If I double-click main.cpp, then I have the code over here for the assignment, etc. So let's go back and see what it says. It says, click OK to any warnings that might show up. So if you have any warnings, you shouldn't have any, but just click OK. Hopefully they go away. You saw that I didn't have any warnings. All right. The second thing we have to do, and I actually should have done this before I launched Visual Studio, but live and learn. You now need to tell Windows where to find the SFML DLL files by adding them to your path environment variable. So let me show you what this means. In order for SFML programs to work, Windows needs to know where the SFML DLLs are. So if I come in here, for example, and I try and run the solution executable that I gave you, it'll say the system, the code execution cannot be proceed The code execution cannot proceed because SFML-window-2 DLL was not found. Okay, so if you try and compile and run the program right now, it's going to give you this error. Okay, so what we have to do is we have to tell Windows where, and like all of these DLLs aren't found, so we have to tell Windows where those DLLs are. And again, I know this is annoying, but it's a one-time thing, and this is the only time you'll have to do it. So we're going back to the environment variables. So let's edit the variables for our account again. And what does it say this time? It says, okay, type env, then click path and click edit. So path, edit. And now it says click new, so we're going to click new. And so it comes down here, there's a new, and we're going to type sfmldir/bin. So in here, I'm going to type sfmldir with percent signs around it, okay? And the percent signs just say, hey, that is an environment variable. So read the environment variable called sfmldir and then put /bin in it. All right. So we're going to click OK, and this path variable, essentially what Windows does is whenever it needs a specific thing to be loaded, it looks in the path to see where that thing is. Okay, so I'll click OK, now I'll click OK, and then click OK to exit. You may need to restart Visual Studio. But before I do that, I'm just going to come over here and I'm going to test to see if that worked by double-clicking the solution file. All right, so the solution file worked. That's great. That means that that step was completed correctly. So before you go restart Visual Studio, double-click that solution file, and if it doesn't work, then you did something wrong in that step, okay? Alrighty, so now, I should have put this step afterwards, but I have to close Visual Studio because Visual Studio also needs to know that path directory. All right, so let's go to Visual Studio again. I'm going to right-click, open with. Now, instead of right-click, open with, right-click, open with, I'm going to click Choose Another App, and I'm going to click Visual Studio 2022, and then say Always use this app to open SLN files. So now, from now on, whenever I double-click an SLN file, which is a Visual Studio solution file, it will open in 2022 instead of 2019. Okie doke. Now Visual Studio is opening again. I will go back to the instructions. So now we're going to compile and run stuff. So it says in Visual Studio, switch from debug to release, and then right-click SFML game project and click build. So debug mode is usually on by default. Release mode is a faster mode. So debug will allow you to do like line-by-line debugging, and I can show you that in a little bit. But release mode is sort of, it's going to be much faster. So later on in the course, if your code seems to be running really, really slow, then you're probably still in debug mode and you need to switch to release mode. Okay? So in Visual Studio, switch from debug to release, then right-click SFML game project and click build. So up here, this is where it says debug, okay? So we're going to click debug, switch that to release, and then we're going to right-click SFML game and click build. All right, so we right-clicked, we click build. This is the output window down here. If there were any errors, they would come up here, and you can see it's a little bit small, but it said 1 succeeded, 0 failed. The reason it says 1 succeeded, 0 failed is because over here in our solution, which could contain many projects, there is one project, and that is called SFML game, and we have just built it. Now, when you're writing code and you're rerunning, you probably don't want to be right-click build, because what you can do is just click local Windows debugger. If you click this, it will build, so it will compile and run your program, okay? So here we compile and run the program. This looks a little bit different because this is not the solution code. This is what I've given you to start with. So that's it. It's all set up. Let me go back to the instructions to make sure there's not anything else. If everything was successful, no errors should pop up. To compile and run in one click, click local Windows debugger at the top of Visual Studio. Here are some common errors. If it says that sfml/graphics.hpp was not found, then you didn't do step 4 correctly, okay, which is the SFML dir, or you didn't restart Visual Studio. And if it says the DLL wasn't found, like we saw a bit earlier, then you didn't do step 9 correctly, or you didn't restart Visual Studio, okay? All right, so now, because this is all, again, done in a virtual machine, and it's a little bit slow, so what I'm going to do is I'm going to exit the virtual machine, and I am going to hop back over to my physical machine where I have the assignment loaded. All right, so let's hop back over. Look at that. How seamless was that? Perfect. So in here, I'm going to do the same thing. I already have the assignment loaded. I'm going to click Release. Then I'm going to click Local Windows Debugger. And that Local Windows Debugger essentially just compiles and runs for you. And so there we go. All right, this is working. I've got a little thing here. So this is going to run in a tiny window. But through the magic of OBS, what's happening is I've got that window blown up to be full screen, and so I can turn that on here just so it's a little bit easier. But it will not look like this for you. I'm just doing this so it's a little bit easier to see on the stream because my resolution is a little bit high. So when you want to stop your running program, I should probably put that down there. If you want to stop your running program, you can either click this X or you can click the stop up here in Visual Studio, okay? So click stop, it all stops. And now over here, we have our main.cpp, and this is the file that you will be editing for your assignment. All right, so that is the complete setup of the environment for the entire year for everybody using Windows, Linux, and Mac. After this, you should be able to just run the make file if you're on Linux or Mac, or if you're in Visual Studio or in Windows, you should be able to just double-click the solution file. It will open for you. You edit some code, you hit Local Windows Debugger, and that's it. Okay, now I realize that down here the font is pretty small. I apologize, it's not easy to change that font size, so I'm just going to leave that like that for now. But the important part is that you can see this font, okay, which is the actual assignment code. So, oh, my mouse is like super dark here. Okay, so I'll keep that in mind. All right, so what we're going to do now is we are going to go look at the assignment file. So, the assignment zip file, once extracted, will contain this, but yours will have like, you know, your information on top and stuff. So it won't look exactly the same, but the code will look exactly the same. All right, so there's a marks file. We're not going to look at the marks file yet because you can't really understand the marks file until you know what the assignment does. But what we are going to do is double-click the README file. So the README file is going to tell us exactly what we have to do for this assignment, like word for word, okay? So let's just read through this because I spent a lot of time writing it. So assignment 1 for COMP4300. And again, if you are watching this and you are not enrolled in the course, these files will not be released to the public, okay? So apologies, but that's all you can do. Please take the knowledge and write your own SFML programs. And for those of you who are not in the class, over here on the SFML website, you can literally just walk through the tutorial, okay? Walk through the tutorial and it'll do the same thing, okay? Alrighty, so there's a bunch of people showing up in the chat who are shaming themselves into not having watched the first half of the lecture where I explained where the assignment is. The assignment will be released approximately an hour after this lecture ends. All right, so let's go over here and we will start looking at the README file. Note, you will be required to submit main.cpp and no other files for this assignment. Submission will take place on D2L, that's our Brightspace, Assignment 1 Dropbox. Only one student from each group of 2 should submit the assignment, okay? So if you're by yourself, go ahead and submit the assignment. If you're in a group of 2, only one person submits the assignment and you just write both your names on it. I don't need to be sent an email saying who your partner is. We will just mark and grade whoever's names are on the submitted assignment, okay? Working solutions are included with the assignment so that you can see what a correct solution looks like. These These are located in the bin directory and provided for 64-bit Windows. So Windows 10/11. If you're not using Windows 10 or 11, then I can't help you. You should probably upgrade by now. Very important. Only submit main.cpp and no other files via D2L. Do not submit main.cpp inside a zip file. Do not submit main.cpp inside a Word document. Do not submit main.cpp with a project file for an IDE. Only submit main.cpp and no other files. Why did I say all of this? It's because all of this has happened. I got someone who copied the contents of main.cpp into a Word document, saved it as a .doc, and then submitted it to me. I apologize if you're watching and you feel bad, but you should feel bad, okay? Now, it turns out that since I've written this, excuse me a second, I have to remove some spam from the chat. There we go. All right, perfect. Banned him. Perfect. We got our first troll of the year. Apologies that had to come up in the lecture, but I had to deal with it. All right. So this has happened, but since I have written this, it turns out that D2L has put in a miraculously amazing feature where I can say only accept a single file and only accept a single file which ends in .cpp. So this, even if you try to do this, D2L won't let you do this, but please only submit main.cpp. Do not create any additional files, any header files, anything like that for this assignment. I know that is good practice to do that, but for this assignment and this assignment only, we are only submitting main.cpp. You must include the following info in a comment at the top of main.cpp, both students' full names, CS usernames, and student numbers. And if you did not get a specific feature to work, please explain what you tried to get working, and I do give partial marks, okay? So if you explain what you tried, what you did, and you show that you did effort, you're not going to get a 0, you will get some partial marks for that. All right, so that's going to be pretty much the same for every assignment, but in the future we'll be submitting a zip file. So a CS username. All right, gotta ban another guy from the chat. Thank you. All right. So someone asked, what is a CS username? Yeah, I guess so. So that is a sort of outdated way of saying this. The CS username is your MUN username. We used to log into the CS department back in the day, and it's ingrained in my brain that it's a CS username, but it is whatever at mun.ca, whatever you use to log into D2L, that's your username, okay? Yeah, so please explain what you tried and if you didn't get it to work, and we can give some bonus marks. So, the program specification. What do you actually have to do? Let's read through it together. In this assignment, you will be writing a C++ and SFML program which will read descriptions of shapes from a configuration file, and then it will draw those shapes to the screen. Each shape will have a name, position, speed, color, as well as properties unique to each shape type. For example, a rectangle will have a width and a height. A circle will have a radius. For this assignment, the position of a shape refers to its SFML default position of the upper left corner of the shape. Okay? So, what does that mean? Well, let's open the file. So if we go into our bin directory, there will be a config file, and we're going to open that here, and we can see that there are a number of different shapes. Okay? So I've got some circles, I've got some text, I've got some numbers, I've got a font over here, I've got a window, etc. So this config file is going to be what describes the shapes that you're going to be drawing to the screen. And if we run the solution here, okay, you can see that this is what happens. Let me full screen that for a second. So here we've got a teal rectangle we've got a blue circle, we've got a green circle, we've got a tiny red rectangle here, we've got a purple circle, and a gray rectangle. So all of those things just happen to be exactly what is described inside this config file, okay? So let me go over here. So the config file says there's a circle that's green. It's going to have a size. It's going to have a velocity. It's going to have a color, and it's going to have some other properties, all right? And I'm going to describe what all of those numbers mean in a bit, but for example, you see this tiny red square here? If I come back and I edit the square, and I believe it's this one, the last one, so this is the width and the height of that rectangle. So if I say that the width of that rectangle should now be 250, and then I rerun the program, then now my red rectangle is 250 pixels wide, okay? So that's what the config file is for. You're going to read all of those properties, and then you're going to draw the correct shapes to the screen with the text centered in the middle. All right, so let's go back here. We will undo that change, and we will go back to the program specification. You are also required to make these shapes bounce off the sides of the window which contains them. This means that if a shape's left side hits the left of the window, its X speed reverses. If the top of the shape hits the top of the window, its Y speed reverses. Similarly, if it hits the right side or bottom of the window. So whenever it hits the left, top, bottom, or right of the window, you're going to make it bounce, okay? You can assume that all shapes will always be configured to start entirely within the window, and you don't have to worry about what happens if they start outside the window. So don't worry about any weird edge case where a shape would start outside the window. Each shape's name should be drawn on the exact center of the shape in the given font size and color specified in the file. A quick note, that may be the trickiest part of the assignment. You won't lose many marks if you don't get it to be correct, but you need to have it exactly centered. And I'll talk about that a bit in a little while. A sample configuration file is given to you in config.txt. However, when we do the marking, it will be done with an unseen configuration file in order to test it more completely. Be sure to add and remove your own shapes to this file to test if they all work correctly. What does that mean? Well, it means that the assignment came with this configuration file, but for example, this configuration file has 3 rectangles and 3 circles. So you could get the assignment to work if you say make an array of 3 circles and make an array of 3 rectangles, but when we test the program, we might have something like this. Maybe there are no rectangles. Maybe there are 50 rectangles. Maybe there is 1 circle. Maybe there's no shapes at all. Okay? So you have to be sure that your program works no matter what options are passed into this configuration file. Okay? So edit that yourself and test to see if you've gotten it working. Each line of the configuration file specifies one of the config settings of the assignment program, with the first string in each line being the type of setting of the rest of the line. Lines in the config file can be one of the following types, and lines can appear in any order in the file. Okay? Now, I'm going to make it a little bit easier on you and say that the window width and height, that is always going to be the first thing in the file. Okay? It makes it a little bit easier, but the window width and height is always going to be the first thing in the configuration file. So this will be the first thing. All right. Someone asked, can the solution files be provided for Linux? No, they can't, because I can't provide a single executable that will run on all Linux machines. Similarly, I cannot provide a single executable that runs on all Mac machines, because different versions of different Mac processors and stuff, they all operate differently, and I can't just give a single one. So if you want to look at the solution, I mean, you just saw the solution. It's pretty intuitive what it does. If you change the settings, the shapes change, okay? So you should be able to see when your thing is working or not, even if you don't have a solution for your particular machine. but blame Linux for that. Please don't blame me. Okay, so this explains what all of the different settings in the config file do. Let me pop this up here real quick, and then I'm going to open up the config file at the same time so that we can try and see what they all are. All right, so one of the lines, so the very first string on each of the lines, that is the type of setting. So for example, if it says window, then the following two things will be the window properties. If it says font, then the rest of the things will be the font properties. If it says circle, the rest of the things will be the circle properties. If it says rectangle, the rest of the things will be the rectangle properties, okay? So keep in mind that I did an entire example. Remember when I did in lecture 2, go back to lecture 2 to the live coding, and I did an example of how to read in from a file in C++. And so I did exactly how you would read in this stuff. Okay. So if it says window as the very first thing, then it is followed by two integers. So this declares that the SFML window must be constructed with width W and height H, each of which will be integers. If it says font, then it's followed by 5 things: F, S, R, G, B. This line defines the font which is to be used to draw the text for the program. The format of the line is as follows. The font file is F, so down here we see that that's fonts/tech.ttf. So I've included a font. The reason I've chosen this particular font is it's a very small file size. It's about 40 kilobytes, whereas something like Arial is like a megabyte, which is crazy. So this is the font. That's the next character. The next thing is S. That is the size that I want the font to be displayed, the font size. The next 3 things are the RGB color that I want the font to be drawn in, okay? So that's 255, 255, 255 in this example, and that means that the font is going to be drawn in white, okay? Next, we have the rectangle and the circle, and there are a bunch of different properties for the rectangle and the circle. So if you see rectangle, it's followed by the following things. So first comes N, that is the shape name. So if you see rectangle, here we have a name which is rred. It could be any name. It could be Dave, it could be Joe, it could be Jane, but I've just called it rred because that's the rectangle red, right? So that's the name. The next 2 things are the X and Y position. So that is the starting position of the top left corner of the object in the screen. So that is 200, 200. And I'm going to give a little bit of a tutorial on that in a bit, but it's just at XY location 200, 200. The next 2 things are the speed, the initial speed of the rectangle. So that means that, so for example here, it's 0.1 and 0.15. And what that means is that the rectangle is going to be moving 0.1 pixels. Yes, we can use floating point to represent pixels. 0.1 pixels in the X direction and 0.15 pixels in the Y direction on every frame of the game. And we'll get into that, how that works in a bit. The next 3 things are RGB. So right here, 255.00. That means that it's 255, so we have 1 byte per color channel. So 255 is the maximum value, 0 is the minimum value. So an RGB of 255.00 means that it is all red, no green, no blue. So this is how you define the red color. If you need a bit of a tutorial on how to specify RGB colors, please go Google that. It should be pretty easy though. You should have all seen this before. And then the last 2 things are the width and the height of the rectangle, okay? So again, you have to write a little loop that reads in all this data from the file, and when you read the data from the file, you somehow input all of that into the shape that you're trying to draw to the screen. So the final thing, which is very similar but a little bit different, is the circle. The circle contains all of the exact same properties up into the end, where instead of a width and a height, it just has a radius. Okay, so instead of specifying the width and the height of the rectangle, you're going to be specifying the radius of the circle. Perfect. All right, so I don't need to go over all these because they're the same as the rectangle. So that is the, configuration file. Here are some assignment hints. Now, the assignment hints, in order to store an arbitrary number of shapes from the configuration file, you must store them in a container. So I recommend using a standard vector. So you have a vector of shapes. I'll show you what shapes are in a bit. And you put those in a vector, and then you can get them from the vector and you can draw them. So a shape will touch the side of the window if its bounding box makes contact with it. And I've got some tips in here. I'll get back to that in a little bit. And please use C++ file reading. So in assignment 2, in the live coding, I did an example of how to read tokens like this from a file. Just copy and paste my code and modify it. Do not use C-style file reading, okay? We are using modern C++ in this course. And despite what you may say about like people online said to do this, people online said to do this, you will lose marks for using older C functionality in a modern C++ programming course, okay? So now what I'm going to do is I'm going to give you a little bit of a primer, but I need to open up something first. So just give me a second here. I forgot to prepare this part in advance, but we should be good once I find it. Where is it? Where is it? Where is it? All right. Okay. Bear with me for 1 second. I think I can do this. Yes. Now, pray that this works. Hey, it worked. Nice. Okay, I've got a blackboard. It worked. All right, so I was kind of nervous about that working. Let me explain to you a little bit about the coordinate system for SFML. So here I'm going to start drawing, and my line size, let me make that a little bit thicker. So here we have, oops, I want to draw in white. Okay, so here we have a square. This is representing the window, okay? So this is the SFML, oh, that is a small font. Here we go. No, still small, wow, okay. I'm just gonna crank her up. SFML window. No, that's not how you spell window, Dave. All right, boom. This is the SFML window. Now, the SFML window is a 2D structure, right? It's two-dimensional. It lives in your computer monitor. It shows stuff in 2 dimensions. This is a 2D game programming course. So the way that you have probably been taught X and Y is in like some geometry class, right? And you are used to 0, 0 being down in the bottom left corner. And then X would increase over here and Y would increase up here, right? So you go up in Y, you go right in X, okay? That is not how SFML works. So I apologize in advance that this is going to be a little bit confusing at first. However, most graphics libraries start with 0, 0 in the top left-hand corner. Okay, so the top left-hand corner is going to be the 0, 0 coordinate, and then X is going to increase to the right. So the X coordinate is going to get bigger and bigger and bigger as you go to the right, and the Y coordinate is going to get bigger and bigger and bigger as you go downwards. Okay, so as you go down, Y is going to get bigger, and as you go right, X is going to get bigger. Okay, so that's the very first thing that you need to know. And that means that if I have a shape and I want to get that drawn at X coordinate, let's say, for example, we have a shape and I want it to be drawn, why is this always so big? Let's say I want it to be drawn at X location 300, Y location 150, okay? And I want it to have a width and a height of 100, 100. Alrighty, so let's draw something that might look like that. So the XY location of 300, 150. So let's just pretend that my grid here is aligned to, the grid in the background, let's pretend that those are 100 pixels each, okay? And what I'm gonna do is I'm gonna erase this stuff, and I'm gonna draw this so that it's actually aligned to a grid here. Perfect. Okay, so what we're gonna do is I want something to be at, let's say, X location 500, Y location 300, and the width and height are going to be 300 wide and 100 high, okay? So the way that this translates in SFML is, again, we have the 0, 0 up here, okay? And we're increasing X to the left and we're increasing Y downwards. So if each of these grid parts are 100 pixels, then our shape is going to start at 500, 300. So we would count 100, 200, 300, 400, 500. And then we're going to go down 100, 200, 300. So the position in SFML specifies the top left of the shape, okay? It's not the middle of the shape. We will actually do that later where we specify the middle of the shape. But for assignment 1, it's the top left of the shape. So someone out there said, it's the same, but it's inverted in the y-axis. Exactly. So instead of y growing up, y grows down. So we have 1, 2, 3, 4, 500, 1, 2, 300 in the y direction. And then we want it to be 300 wide and 100 high. So that is what that shape would look like. Okay, so this shape right here starts at XY. This is 500, 300, and the height is 100, and the width is 300. Okay, that's how that works. Now, if I had a circle, for example, and I wanted the circle to be at, let's say, 200 in the X direction, and let's say 100 in the Y direction, and the radius of the circle, let's say the radius is going to be 300, okay? So how would I draw that one? Well, I'm going to start up at 0, 0, and that keeps deleting for me, so 0, 0, and I'm going to go 100, 200, and then I'm going to go down 100. And what I'm going to do is I'm going to start drawing a circle here, and it's going to have a radius of 300. Now, it just so happens that Microsoft Paint did this exactly how SFML will do it. Okay, if you were in Photoshop or something, it may be different, but the 200, 100 location specifies the top left corner of the bounding rectangle of this circle. Okay, see how the top left corner of the bounding rectangle of that circle is up there? So this is really fortunate that there's this like dashed line in Paint. That won't be in SFML, so I'll just click it. Okay, so this is what it will look like in SFML. However, the location of the circle is specified, by the bounding rectangle. So this rectangle, all right? Oh, I'm a fool. Apologies. Who can tell me what I did wrong? I just drew the diameter of 300 when what I wanted was a radius of 300. So a radius of 300 means a diameter of 600. So 1, 2, 3, 4, 5, 6. 1, 2, 3, 4, 5, 6. So that is actually what would be drawn. And that is because this is the radius. That was all a test, and you all failed for not, right? I'm just joking. That was my mistake. So this is what would actually be drawn because the radius of a circle is half the diameter. All right. So that is the SFML coordinate system. Now I had a little bit of a hint back here. Let's open the README. And we're going to switch back to this for a second. There we go. So the README said, a shape will touch the side of a window if the bounding box makes contact with it. each shape's bounding rectangle can be obtained via shape.getLocalBounds. So if you call shape.getLocalBounds and then say .top or .left or .width or .height, that will give the local position of the top left of the rectangle. Local means it's relative to shape.getPosition, not the window, as well as the width and height of the bounding rectangle. Okay, so what in the hell does that mean? Well, let's go back to the blackboard and I'll show you what that means. So we're going to erase a little bit of this. All right, so let's say I do have a circle. Okay, so this circle here has a radius of 200. If I ask SFML, what is the position of that circle, it will give me this XY location. Okay, this one right up here that I just explained, this little dot right there. Okay, that is the XY location of the circle. Even though the circle doesn't touch that spot, it's the top left corner of the bounding rectangle of the circle. So, if I want to know if this circle is touching the side, right? So here we go. Let me do this like in a sort of really funny way. So I'm going to try and here we go. So as this circle is sort of moving around like the DVD logo, we want it to bounce, right? We want it to bounce. Boom, 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 boom. Okay. People are asking for installation tips. That is not something I'm going to go into. Trust me, it works. You're just doing it wrong if it didn't work. So we want this to be bouncing around like the DVD logo. How are we going to tell when this thing touches the left? Okay. So let me put that back. So if we want to know if it's touching, we have to do 4 different checks. Okay. We have to check whether or not the left-hand side of the circle is touching the left wall. We have to check if the top is touching the top, if the right is touching the right, or if the bottom is touching the bottom. So, how do we know when left is touching left? Well, left is touching left when the following things happens. If the X location of the circle is less than 0, then we know that the left-hand side of the circle is touching the left-hand side of the window. See how that works? So the X location of the circle is going to be changing until it hits 0. And when the left-hand side of the circle hits 0, we know that we're touching the left-hand side. Similarly, when the top of the circle, its Y position, is less than 0, we know that the circle is touching the top. Okay? Now, it's a little bit harder to figure out the right-hand side of the circle, but what would the right-hand side of the circle be? So what is the coordinate of the top right corner of the circle? Well, let's figure that out. So the Y would be the same, right? So we're trying to figure out the X, and the Y is going to be the same thing. So someone said, take the X position and add the width. Exactly. So the width of a circle is the diameter, right? So that would be X plus 2R, that's the radius, and then the same Y, right? Down here, if we want the bottom right, we would have X plus 2R, and then Y plus 2R. If we wanted the bottom left, we would have X, and then Y plus 2R, okay? So if we want to know if the right-hand side is touching over here, we would have X plus 2R greater than the width of the window, right? So instead of being X less than 0, we have X plus 2R greater than the width of the window. So there's a little bit of math here. It's not so bad. But what this said back here was that we can actually get the width and the height from the set or from the getLocalBounds function on the shape. So what getLocalBounds will do is for a circle or a rectangle, it will give us the width and the height. So if I do call getLocalBounds, we will get width. So this is X plus width, Y. Down here, it will be X plus width, Y plus height. And down here, it would be X, Y plus height. Okay? And so what you would do in order to detect if the circle's right-hand side is touching the right wall, is you would say, is x plus width greater than the window's width? And if you want to check if the bottom is touching the bottom of the circle is touching the bottom of the window, you would say, is y plus height greater than the window's height? Okay. Now it's y plus height because height decreases, or sorry, y increases as we go downwards. Okay. So that's basically what you need to know about the shapes for this assignment. Okay. What you need to do with the text is you need to center the text exactly in the middle of the text, in the middle of the shape. So let's say that we have some text, and I'm going to type the text down here. This is going to be my name of the shape, okay? So let's put this down here. And what I want to happen is for that name to be exactly centered in the circle. That means that the middle of the height of the name is in the center of the circle, and the middle of the width of the name is in the circle as well. If you do something like this, where the name is on top of the middle, that is not correct. If you do something like this, that is not correct. Or this, I want this, where it's exactly centered in the circle. And you can go look at the SFML tutorials, as well as what I've said so far, in order to center that name of the shape properly. Okay, the last thing that will happen is that each of these shapes in the configuration file is given a speed of sx and sy. All right, so sx, is going to be the amount that this shape moves by every frame. So if this shape had an sx of 100 and an sy of 0, it would mean that on the next frame, the shape would move right here. Now, it wouldn't move slowly like that. I'm a human. It would instantly teleport 100 to the left. Now, if we're looking at 60 frames per second, then it would be off of our screen instantaneously. So that's why I have something like 0.1. Right? So what's going to happen to our red shape, if I go over here and I look at the config file again, our red shape has an x speed of 0.1 and a y speed of 0.15. So at 60 frames per second, which we're going to limit our thing to 60 frames per second, it's going to move 0.1 per frame. If we multiply that by 60, then that'll be 6 pixels. Or is it? Yeah, so 6 pixels. So 0.1 times 60, we have 6. So every second, the circle will be moving by 6 pixels to the right. And what's 6 times this? 90 and 90 pixels down. Okay? Now, here we're going back to the blackboard. Someone asked about limit or locking the frame rate. You can never lock a frame rate, okay? You can only ever limit a frame rate. And we'll get into that later in the course. We have an entire lecture on that, but we are limiting our frame rate to 60 frames per second. Okay, so the last thing, I said that was last, but is this moving? So make sure that you add that properly. And the last thing is that when a shape bumps, so for example, if a shape is moving to the right and it hits the right, it's going to start moving in the opposite x direction, okay? And if it moves down and bumps, then it's going to be moving in the opposite y direction. In order to accomplish that, all you have to do is change the speed in the x direction to negative whatever the previous speed was, okay? So if it's moving positive in the x direction, it's going like this. And then if you change that speed to negative, it will look like it bounced and start heading in the opposite direction. Similarly, if it's going positive in y and then you flip it, then it will be going negative in y. All right? So that's how you implement the bouncing. Okie doke. Let's go look at some code, shall we? Alrighty. So this is our main program for our assignment. There is only one function. It's just the main function. You are free to add whatever code you want to this as long as you keep it entirely within the main function. Okay, so you can add, as long as you keep it within the main.cpp file. You can add any functions that you want as long as you keep it all contained within this one file. All right, so let's go through this code, and I'm going to explain all the code as we go. I'm going to explain the whole thing, and then I'll make some changes and show you how it changes and give you a little bit of tutorial. Alrighty. Okay. So I've got a mistake here already. That's good. Here we go. So the first thing we want to do in our program is create a window. Okay. So the way we do that, oh, and just as an aside, please go to the SFML website. If you're new to SFML, you can click Learn. You can click Tutorials, and then you can look at these tutorials, and it is amazing, okay? It'll explain everything for you in plain English. Like, for example, here's how you open a window, right? Here are different properties of a window. Here's how you would bring the window to life. So you're going to have a main loop, all that kind of stuff. So please go read this. If there are things that I'm about to say that do not make sense to you, go read this tutorial. This is sort of your homework. What you should do for this assignment is you should read Opening and Managing a Window. You should read Events. You should read Drawing 2D Stuff, Sprites and Textures, Text and Fonts, Shapes, Position, Rotation, and Scaling. Okay, those are the things that you should read for this one. So again, Opening and Managing a Window, Events Explained, Drawing 2D Stuff, Sprites and Textures, Text and Fonts, Shapes, Positions. That is all we are going to be using for assignment 1, and it turns out it's actually pretty easy. So here's our code. We are going to define a width and a height for our window. Now, of course, because you're doing the assignment, you are going to read in the width and the height of the window from the file. Okay, so for example, if I run my program now, I'm going to have this show up. Okay, this is a bit strange. I've just got a green circle moving with some sample text down here. So let's change the window size. So let's change this to 1280 by 720. All right, now I'll rerun it. And you're going to see that my window size is much bigger now. So I've got a screen that it's 1440p, so it may look smaller to you on your monitor or bigger to you on your monitor, but on mine, it's this size, okay? So what I'm going to do now is I am going to click this, so this goes full screen, so you can see this a little bit easier. So you see a green circle, it's moving kind of slowly to the top left here, and I've got some sample text down here in the bottom. So let's look at how this works. All right. So we're first going to make a shape that we will draw to the screen. And the way we do that in SFML, and again, please go look at the tutorials for a better tutorial than I'm about to give, is an SF circle shape. So just like we used STD or standard for like things like standard vector, SFML is contained within the SF namespace. So all of the objects that we're using and the functions that we're using from SFML are going to be preceded by the SF namespace. So this is an SF render window. It's a window. And the constructor to a window takes in a video mode with a width and a height. You can also specify other options. That's in the tutorial. And then you give it a title. And my title for this window was SFML Works. Yay. Now let's make a shape that we're going to draw to the screen. So here is how we define a circle shape. We can just say SF circle shape. We give it a variable name, and then we pass in some constructor arguments. And this is going to be a circle with a radius of 50. Okay, so a radius of 50 means it has a diameter of 100. I'm going to set the fill color. So once I've created the object, I can set a number of its properties with the functions on that object. So for shapes, I can set a fill color, meaning what is the color of the interior of that shape. So if I change this to red, for example, then I run it again, I am going to have a red circle, hopefully, on the screen. And I do. I have a red circle on the screen. Great. So I'm going to keep that as red for now. But what if I wanted to change this color using an RGB value? Okay. So for example, let's say someone was given an assignment where they had to read in RGB values. So I'm going to say int R equals 0, int G equals 255, and int B equals 255. So green and blue mixed together at full power. So 0 is 0 and 255 is full. We are going to create a teal color by mixing green and blue. And the way I can specify a color, so SFML has a number of colors built into it. And the really cool thing, one of the really cool things about Visual Studio is the IntelliSense and the autocomplete. So if I say SF color and then I go : : it will list for me, and I know this is a bit small, all of the things within that namespace, okay? So within color, I can see, oh, there's a bunch of colors defined, like blue, black, green, magenta, and I can just select one. However, what I want to do is actually specify a color manually using RGB. So let's go SF color, and then I can pass in my RGB variables that I may have read from a file, for example, right? So this R is going to be 0, the G is 255, the B is 255, but they could be anything. And then I'm going to run this again, and now I should see that I have a teal circle going through. Or maybe you call that cyan, I'm not sure. Alrighty, so let's continue going. Now what happens is we're going to set the position of the circle, all right? So that position is going to be at 300 pixels in the X direction and 300 pixels in the Y direction. So that's 300.0f because this takes in a float, and 300.0f in the Y. So that means that when we start our program, that circle is at 300 in the X direction and 300 in the Y direction, but it's also moving, so it doesn't stay there for very long. We are going to set a variable. I want my circle to move a little bit, so I am going to set a variable here to move the circle, okay? And essentially, what I'm going to do is every frame of the game, I'm going to move the position of the circle by this amount. So this is 0.01f. Now, if I change it to 0.1f, it's going to be moving 10 times as fast as it just was. So just watch, right? It's moving really, really fast. So one of the reasons it's moving so fast is because I haven't specified a frame per second limit, okay? Meaning that my monitor is 144 hertz, I think, 165 hertz. So that's it's going pretty quickly. And if you don't specify one, then this is actually like one frame is happening for each refresh of your screen. So what we're going to do here is we're going to say window.set frame limit, and this is going to be 60. So this is going to mean that we are not going to do any more than 60 frames per second. So if I click it again, then what's going to happen is that 0.1 speed is now much slower because it was operating at like 144 times per second before, but now it's operating at 60 times per second. And at 0.1 pixels per frame, this is moving at 6 pixels per second, which is pretty slow. So if I come back here and say, let's say we make it to 1, right? Now that will be moving 60 pixels per frame, which would be about 5 seconds to reach the corner, okay? 1, 2, 3, 4, 5, okay? I forgot to count at 0. But you can see now we can start to talk about speeds, pixels per second, all that sort of thing. So we've set our frame limit here. Alrighty, so I'm gonna change this back to let's say 0.5. And now what we're gonna do is I wanna draw some text to the screen. So how am I gonna draw some text to the screen? Well, I'm going to use SFML's amazing built-in font handling library. Thank you, SFML, because in OpenGL, this is a nightmare, okay? So this is one of the reasons we're using SFML. So I'm going to create a font object. And again, there is tutorials for this on the website over here. If you go to text and fonts, you can look at all of this, okay? And I've included for you a font called tech.ttf. That's inside the bin directory in the fonts folder. So what happens here is we call font.load from file with a file name. This, if I hover over this function, it's going to give me the function signature. I know this is impossibly small. I'll try to increase that in the future. But this function, load from file, is going to return true if I loaded the font successfully and false if I didn't load the font successfully. So what happens here is if this returns true, then I'm saying if not this. So if this returns false, I'm actually going to go in here because I have an error. So this is a little bit of error handling, okay? And error handling is a good thing to have. So this essentially says, if I couldn't load my font, print out couldn't load font, and then exit with an error code of -1 instead of 0, meaning something went wrong. Something went wrong in my program, okay? But if it did load the font, nothing will be printed out. It'll just go on. Now, so that's the font. That's the font that's going to be used to draw the text. Now we have to set up an actual text object. So in SFML, we have SF text, okay? That's our text object. We're going to call that variable text, and we have sample text here as the text, and this is going to be using my font as the font, and here we have the character size of the font. You may have to read this in from the screen, but if I run this again, you'll see down in the bottom left, that is where my sample text is. How am I going to actually position that? Let's say I wanted to position it in the bottom left of the screen. How am I going to do that? Well, I'm going to need two things. I'm going to need to get the width of the window, or sorry, the height of the window, and I'm also going to need to get the size of the character, right? Because if I go back here to my Blackboard, whenever I draw text, so sample text, what I'm going to do is the top left corner of this sample text, that is where the text is, that's the position of the text, okay? So if I want to position my text, if I say draw the text at X location 0, Y location height, then it will actually be drawing the text right here because it's the top left of the corner that I'm specifying. If I wanted to draw like this so that the bottom of the text aligns with the window, then what I have to do is set the Y, instead of setting it to just the height of the window, because again, Y increases downwards, I have to take Y and then subtract the height of the text, right? So this is the height of the text right here. And so I need to take Y, which is down here, subtract the height of the text, and that's where I put it. So the way I can do that in SFML is I'm going to say text.setPosition. Well, 0 is fine in the X because that's aligned with the left, right? Then I'm going to take the window height and subtract the character size of the text. So text has a function called character size, and I can get the character size that way. And if I want to say, for example, look at all the different functions that are on text, I can say text dot, and then Visual Studio will very nicely do the autocomplete for me and do this. Okay, so I can say, oh, look, get font, get origin, get local bounds, get letter spacing. It's really nice, that autocomplete. If you are on Linux or Mac and you use VS Code, you can use VS Code, and if you install the C++ extensions for VS Code, you will have the same type of autocomplete. But just realize that VS Code does not have a compiler. You'll still have to do that outside command in your terminal. Okay, so now we've gotten a shape that we want to draw, and we've gotten some text set up with a font. How do we actually run our game, okay? So if all we had done was set up a window and say, new window, that's it, then the program would run, set up a window, and then immediately exit, okay? So what we have to do is we have to set up what's called a main loop. And a main loop is running all the time, right? So essentially, it's saying, while my window is still open, draw stuff to the screen for me. While my window is still open, capture some mouse and keyboard events. So this is looping as fast as it can, or if we've set a frame limit, it's looping at that limit. So this is looping 60 times per second, and it's doing whatever's in that loop every 60th of a second, if we have set our frame limit to 60, okay? So, the first thing we can do is we can do some events, okay? Now, again, in the tutorial, back here, there is events explained. So you can go read this if you want more detail on events. But what we can do is we can set up an event loop. So in SFML, it comes with an event class. So we're going to set up an event object. And essentially what we're saying is every single frame that the game is displayed, check to see if any mouse or keyboard events have happened. And if they have, then let's do something, okay? So we set up an event, and then the way that SFML happens to work, other libraries work differently than this, or they may work the same, is we're going to call window.pollEvent and then store it in the event object. So the window stores a list of all the events that have happened since the last frame. It's going to poll the next event, and then we're going to loop over that. So window.pollEvent is going to return true if there are more events. Otherwise, it's going to return false, and this loop will exit. So if we're inside this loop, it means that an event has happened. So now I need to determine what type of event it was. So here, as an example, it says, if the event type is window closed, then window.close. So this is actually kind of funny. Let's say this might be like really intuitive, but it's kind of not. So let me take out the window.close. So this SF event closed, that is an event that happens when you click the X in the window, okay? So if I click the X right now, you can see that nothing is happening. So by default, clicking that X doesn't actually mean anything. It's just a type of event, okay? So I'm going to stop. So for example, if I had said standard cout, close clicked, then whenever I click that X, I'm going to see in probably small font in the top left up here, close clicked. See, every time I click that, it's printing that out to the screen, but it's not closing because the X on its own doesn't actually close a window. We actually have to say, hey, window, when I detect that that X has been clicked, please close the window. Alrighty. Let's do a keyboard event now. So if the type of event was a key press, meaning that you've pressed down on the key, let's do something. So first thing I'm going to do is I'm going to print out the key that was pressed, okay? And so if I run the program and I press like A, it's going to say key pressed with code 0, B, key pressed with code 1, C, D, E, F, and these kind of go up. So you can see that there's some sort of integer associated with each key press. If I press 8, it's going to draw this. If I press like Shift, it has something, Control, spacebar, they all have key codes associated with them. So what do I want to do with that key code? Well, I'm going to say if a key was pressed, for example, if a key was pressed and the code of that key was equal to the X code, so inside SFML, we don't have to remember all of those integers because there's a namespace here, SF keyboard, and if I type : it will actually list all of those for us, okay? So if I type X, then what's going to happen? Well, let's do something, right? I could just print something out, but let's have something more interesting happen. So what's going to happen here is I'm going to change the sign of my circle move speed, okay? So that means it says whenever I press X, change the circle move speed to be the negative of what it just was. So if I do that, now if I hit X, the circle's going to go in the opposite direction. See that? I hit X, circle in the opposite direction. I hit X, circle in the opposite direction. Similarly, I could do something where I say window.close, right? So let's say now if I hit X, what's going to happen? Well, now if I hit X, the window closes, right? So I can do whatever I want based on these. Now, when we get a bit further in the course, I'm going to talk about mouse inputs. We're not going to talk about mouse inputs for assignment 1. All right. Let's talk about animation. So animation is very simple. Animation essentially is drawing something, like if you talk about real physical like Disney animation, it's a bunch of drawings that are shown to you in sequence, right? So you draw one thing, then draw another thing, then draw another thing. So on one frame, it's like this. Next frame, it's like this. Next frame, it's like this. You put those all together really fast, 24 frames per second or whatever, and you have what looks like a moving image, okay? It's the exact same thing for every video game ever. You render a circle here. On the next frame, you render it here. On the next frame, it's here. On the next frame, it's here. And then your eyes get tricked into thinking that it's moving when it's actually static, but every 60th of a second it's moving, okay? And what we're going to do to create this animation is we're just going to set position of the circle to something new every frame, okay? So let's go back. Here, what we're going to do is every frame, and again, when we're inside this loop, while window.isOpen, we are essentially every frame this is called. So circle.setPosition, well, how are we going to set that, right? Well, let's go back to the blackboard. If I want to update the position of this circle, well, the circle has a current XY position, right? I want to get a new X and a new Y position. So the new X position is going to be equal to, let me move this over a bit, the previous X position plus the speed in the X direction. And the new Y position is going to be equal to the previous Y plus the speed in the Y direction, right? So how am I going to do that within the SFML syntax? Well, I'll show you. Back here, I can say circle.setPosition, and now this takes in an X and it takes in a Y. So for the X, I'm going to say that I'm going to get the previous position of the circle, which is circle.getPosition.x, and I'm going to subtract the circle move speed. Now, you could add, you could subtract, doesn't really matter, right? Well, I guess if you want to add, yeah, so technically this should be plus, and this should be plus. I don't know why they're negative right here, but they'll be plus when you get it. So now, every frame, the X of the circle is going to be updated with the circle move speed, and the Y is also going to be updated with the circle move speed. Now, if I had just said +0 here, right, as the Y position, then what's going to happen? Well, the X position is going to get updated, but the Y position isn't, right? So let's make some variables here, because you are going to have to read these variables from a file. So if I say this is the speed of X, and I set that equal to 1, all right, let me do it float, because it's going to have to be a float. Float SX equals 0.5, and float SY equals 2.0, okay? So down here, now this is going to be SX, and this is going to be SY. So that means that my circle is going to be updated by 0.5 pixels per frame, and my Y is going to be updated by 2 pixels per frame. And that means that it's going to be going down 4 times faster than it is going across. So here we go. As you can see, it's moving down a lot faster than it is moving over. Okay, so that's how you deal with those. Okay, so let's go back to what it was. Actually, I'll leave it like this, but I'm going to change this to 0.5 instead. All right. And this is SY. Perfect. So the last thing we have to do is actually tell the window to draw stuff. Okay? So what we do first is we clear the window. Let's look at what happens if we don't clear the window. If we don't clear the window, then we draw every frame and we never erase what was there before, right? So this is actually kind of cool. You can create like a paint program with this. Actually, I encourage you to play around with stuff like this. It's really, really neat. So if we don't clear what we drew before, then it will just draw on top of it. So make sure we clear what we had before. Then in order to draw this shape, it's so easy. We just say window.draw circle. And in order to draw our text that we set up here, we just say window.draw text. And then window.display, this handles the OpenGL buffer swapping under the hood. And what that essentially means is that under the hood, if you want to know the details, OpenGL stores actually two windows, okay? And so they're called buffers, display buffers. So it will have what's currently being drawn to the screen in one buffer, and then it will be drawing, whenever you make these draw calls, it will draw to the other buffer behind the scenes. And then when you call window.display, it swaps the buffers. So whatever you just drew to in behind the scenes is now what's being displaying. And whenever you call draw in the future, it's going to be drawing to the other buffer. So this is called double buffered, and it's swapping the buffers. So the display actually does the swapping of the buffers. And if we didn't do the swapping of the buffers, what would happen? Well, actually nothing. It wouldn't even update the window because it's not swapping those buffers. Okay, so the display never gets updated unless we call window.display. So the general thing we want to do is every frame, we move all of our shapes, we handle all of our input, we update our animations, whatever they may be, we clear the window, we draw the shapes, and then we display the window. Okay, that is basically it. And throughout the course, what we're going to be doing is creating like a nicer architecture for this, okay? So we're going to have multiple classes. We're going to have like a game engine class. We're going to have a scene class. We're going to have entities and stuff. But the very basic outline of any video game is this 100 lines of code. It's set up a window. You have a main loop. The main loop handles inputs on every frames. The main loop updates your game logic every frame, and then it renders every frame. Now, of course, modern game engines are going to be multi-threaded, so they're going to be way more complicated than this. We're not going to be getting into multi-threaded stuff in this course, but we will talk about more complicated structures for main loops later on in the course. But that is basically assignment 1. What you have to add to this is just the file reading, and then here you might have to draw an SF rectangle shape. Okay, so rect, and then you can say the size is going to be, now, when you have to construct a rectangle, you can do something like this. So you can say SF vector 2F, that's a 2D vector. This is going to be my rectangle size, and then I'm going to pass in, let's say that's 300 wide and 100 tall. So I'm just giving some more tutorial here. If I want to set up a rectangle size, I can do that. So let's say I read in a float Rx equal to 300 and float Ry equal to 200. Here I can set up a size, which is a vector 2f, which is essentially just a 2D vector with an x and a y component that SFML uses very heavily. We will be rewriting this later in the course. And then I can construct a rect with the R size, okay? Like that. Then later down here, what I can do is I can window.draw my rect. What was that called? Where did I set up my rectangle? Rect, okay. Perfect. Now if I do this, what we have should be a white rectangle up at the very top left. And the reason it's at the top left is because its position was not set, okay? If I set the position, so if I come back up here to my rectangle, now I say rect.setPosition, and I'm going to set this to maybe 100 in the x direction and 5 in the y direction, all right? That means it'll be over to the to the right a bit and down a little bit, right? So 5 pixels here, 100 pixels here. Then I could say rect.setFillColor. Let's say SF, what do I want it to be? Let's say I want it to be yellow. So I can say SF color, I want 255, 255, 0, because that's a combination of red and green, which makes yellow, believe it or not. So now we'll draw yellow to the screen. Okay, so we've got a yellow rectangle. And let's say that we want that yellow rectangle to have a border that is red. Okay, so let's say rect.setOutlineColor, SF color. I can use the other syntax as well, right, for red, and then rect.setOutlineThickness, and I can say the outline thickness is going to be 20 pixels. So now if I do it, I've got a yellow rectangle with a 20 pixel red outline. See how that works? Isn't that really cool? It's really easy to use SFML, and that's why we're using it in this course. And we will be making big use of this in assignment 2. And I can also do something, just watch this. Down here, I can say in my main loop that happens every frame, I can say rect.rotate 0.1, and then that's going to rotate the shape for us. And look at that, now the shape is rotating. Isn't that cool? So it's really easy to do stuff like this and create animations and create games. The only other thing that you're going to have to do on your assignment is that you are going to have to create multiple shapes. Okay? So what you're going to have to do at some point is you're going to have to do something like this. So you're going to say standard vector. Now, there's 2 ways to do this. You could say, have a vector of SF circle shapes, right? Circles. And you could have a SF or standard vector of SF rectangle shapes, and this is called rectangles. Now, for example, what I could do is I could let's say I create another rectangle. This is going to be rect2. Okay, so I'm going to create another rectangle. The position of this one is going to be at 400, 200. It's going to be red. It's not going to have an outline. All right. So now what I can do is my circles, I'm going to say circles.add, or sorry, .pushback, because it's a C++ vector. I was using JavaScript recently. Now I'm going to add my circle that I created up here, circle. So circle, pushback circle, and my rectangles .pushback. I'm going to I created rect, and I also created rect2, right? Down here where I draw stuff, instead of drawing rect and instead of drawing circle, what I can say is for auto reference, we know what this means now, in circles. So that means for every circle shape, I have to call it C, or call it anything, I'll call it circle. So for each circle in circles, window.draw circle. Okay. And then for every rectangle, so for auto rect in rectangles, I can say window.draw rect. Alrighty. So hopefully that worked. And now we're going to see all of those things being drawn. And it does. Perfect. Let me show you something a little bit more interesting now. Instead of manually creating 2 rectangles, let me do the following. So down here, instead of adding those rectangles, I'm going to say for int I equals 0, I less than 10, or I say for x equals 0, x less than 30, x plus plus. Now inside that, I'm going to do for int y equals 0, y less than 15, y plus plus. Just some interesting values. Watch this. I'm going to create a rectangle. This rectangle is going to be at position x times 20, y times 20, then I'm going to set the fill color to, let's do this to 25 so I can do something really cool. So the fill color is going to be X times 10, and then Y times 10. So this is going to go from 0 to 250, and this is going to go from 0 to 150. I'm not going to have an outline color, but I am going to say that the size is going to be SF vector 2F, and this is going to be a 10 by, or maybe a 15 by 15 rectangle. All right, so this rect, I'm going to put into rectangles, dot pushback rect. All right, so now what I've done is I've created a grid of rectangles, 25 wide and 15 high. I've scaled their color to be more red in the X direction and more green in the Y direction. So hopefully what we see is in the top left, shapes will be black, but in the bottom right, they'll be yellow, and they'll be in the bottom left, they'll be green, and in the top right, they'll be red. Hopefully I did that correctly. Let's see. So once I add my shapes into this vector, I've already got the code that draws all my rectangles, right? I'm not worried about the circles right now. So let me erase that. So I will render this. Look at that. It worked. Cool. So that's how you would do something like that. Okay? Pretty neat. That is what our course is going to be, is we're going to learn more and more every lecture. But let me put it back to the way that it was so I can finalize things by saying what you're going to see on your assignment. Okay, so this is looking a bit... Let me go back. I don't want my rectangle. I got my circle move speed. Don't draw the rectangle. So yeah. So this is kind of what it's going to look like on your assignment, right? It's going to look like this. It might be a different color. That's fine. And you are going to turn that into this. Okay? So you are going to be reading all of those properties from the file, and then you are going to make them all move with the proper speeds. You are going to make them all bounce off the walls, and you are going to draw the names inside the objects of the correct color. One other thing that I might suggest is that what you essentially have for each of your shapes is you have the shape properties and you have a speed. Most of the shape properties you can actually store inside the SF shape itself. So what you may want to do is up here, you may want to create your own class, which is assignment shape or something like that. Inside that assignment shape, you can just make it all public. And you can say that, okay, the assignment shape is going to have an SF shape. Okay, XF shape. Now that's going to be either a rectangle shape or let's just say it could have a circle shape. It could have a rectangle shape. And maybe it has a speed. Okay, speed X, speed Y. You could make your own class for that if you want to. All right, you can do that. Or down here, when you have your vector of rectangles, you could say SF vector standard vector SF rectangle shape rects, and then you could also have SF vector float of like rect X speed, etc. I'm not going to tell you how to do this because I want you to do that yourself, right? I want you to figure that out. The last thing I will say, however, is about inheritance. So, SF circle shape and SF rectangle shape both inherit from the same base class. They are derived from the... Oh, sorry, I had a question. What determines the way shapes overlay one another? Yeah, so whatever was drawn first is on the back, and whatever was drawn more recently is in the front. Thanks, that's a really good question. So let's say that I did have that rectangle shape, okay? So this is going to be SF vector 2F, and this is going to be at like 100, 100. Okay. Let's say I have a bunch of shapes. How can I store all of those shapes in the same vector? So before I said, okay, we're going to have a standard vector of SF rectangle shape, call that rectangles, and we're going to have a standard vector of SF circle shapes, and we're going to call that circles. What if I wanted to have one vector that contained them both? Okay, so that is a little bit more complicated, but I want to show you how you could do that if you wanted to. So in order to create a base class, so what you would have is they both inherit from SF shape. Shapes. Alrighty. So rectangle shape, and it's a 4th year course, you should know this about inheritance. Rectangle shape inherits from shape. Circle shape inherits from shape. Therefore, I should be able to store all of my shapes within one thing. All right. So in order to store, actually, let me see if this just works. This might work, and I'll be very humbled if it does. Let me go down here, and I'm going to write for auto shape in shapes window.draw shape. Okay, so that's the code. That's all the code we would need to draw all of our shapes. We're going to not draw that circle just yet. And I want to see, I don't think this will work, but let's try shapes.pushback rect. Will that work? Apparently it does. Shapes.pushback circle. And now if we run this, will this give me a runtime error? Okay, there's a build error. Perfect. Yeah. So what happens here is that you can't just add these into shapes. You have to set up a base class pointer to the derived class first. So I would have to say shape. So let's see here. How would I do this? So SF, I haven't practiced this, so I apologize if I get I would have to have SF shape pointer. Now I'm doing this. I know I said not to use pointers, but I'm going to try this at first to see if it works. This is going to be my shape equals new SF circle shape, and that is going to be 20. Okay. Now I'm going to say, and this is going to have to be pointers to these shapes. Okay. I may actually be able to do that. Okay. There's a lot of different ways to do this, and I'm trying to find the least confusing way. And now I can say shapes.pushback shape. Alrighty. And now down here, I would have to draw the actual, I have to dereference that and draw the shape. All right. So that works, and I'm drawing that shape up here. Now, I talked about shared pointer before. If you don't want to get confused by this, don't worry. You don't have to do things like this. But if I include memory in here, I no longer have to use these unsafe pointers. Okay? So I could say standard shared pointer SF shape. Okay? So this is how I would declare it. My shape equals standard make shared SF shape, SF circle shape, and then 20. So this is the safe way to do this so that you don't have to worry about manually freeing that memory later. This is very verbose. And so it's verbose, but you know, that's fine. Now what I'm going to do is up here, I could say standard shared pointer to an SF shape. And then my shape is going to be pushed into there, and I'm going to draw it. So let's do that. Okay, so that works. Then, if I wanted to, I could also say, I'm going to make this kind of the same thing, but this is going to be a rect, and this is going to be a circle. So I'm going to create both, and then add them both. Okay. However, this shape, oh geez, sorry, I'm going a little bit fast here because I'm a little bit over time. This is going to be a rectangle shape, and this is going to be of size SF vector 2F 40, 40. And just so it's not drawing on top of the other one, oh no, what's going on here? Okay, hang on. Oh, variable redeclaration. Thank you very much. I have to get rid of that one. Thank you for the chat for doing that. You are great. I was losing my mind there for a second. And now rect, I'm going to call set position. And then I am going to set the position to 400, 400 so that it's moved a little bit. So now I've got a rectangle shape declared as a base class shape, a circle shape declared as a base class shape. I've got a vector of shapes, base classes. I can put them both into the same vector, and then my one line of code draws them all. There we go. So I've got my circle up here, and I've got my rectangle down here. So you could either go with a vector of circle shapes and a vector of rectangle shapes, or you could use this, and you could go with a single vector of all the shapes. Okay? All right, I know that was a lot and I went a bit over time, but again, I wanted to give you as much, and we spent so much time of this assignment going over the setup, and that's a one-time thing. It's a very one-time thing. So I know all of my live coding goes a little bit long, but it's for your benefit, right? So you have more stuff to do, or more information about the assignment. So just as a quick note, this assignment will take 12, you have 12 days to hand this in. Please do not wait until the last minute. Please set up the assignment as soon as possible so that if you have, like, if I was a betting man, I would bet that I'm going to get 15 emails on the day that this is due saying that they can't get Visual Studio to work, or they had problems setting it up. On the due date, I am going to get 15 people, okay, 10. I'll give you guys the benefit of the doubt. On the due date, on September 27th, I'm going to get 10 people saying that there were problems with the setup instructions. I bet you. Please don't do that to yourself. Go do it now if you can. At least go install Visual Studio 2022, right? Or go do those Linux commands, right? All right, so that's it. You got 12 days to do it. Don't leave it for the last minute. Please post on Discord when you want help. I'm always available. Well, not always available. I'm usually available and reply pretty quickly. All right. Someone asked a question. Are these window.draw functions multi-threading safe? I don't know, and I don't care to answer because we don't do that. The assignment, if you are watching this live right now, the assignment will be released within an hour. Okay? Within an hour from right now, this assignment will be released. If you are watching this at a later date, the assignment has already been released. I just need to make a few edits and upload them, and then it'll be working. I will post on both D2L and Discord when the assignment has been released. Okay? It should be within an hour. At the very latest, it will be this evening. But I will post on D2L and Discord when the assignment is released. I'm so excited to actually start to get programming with you all this term, because this course is so fun. It has a little bit of a slow ramp up because, you know, we can't let anyone fall behind right away. Some people may already know all this stuff, and I apologize to you people that you have to look at all this again, but some people definitely don't.
And you probably didn't know everything that we did here today. So we're going to start slow with assignment 1, but trust me, assignment 2 is going to be a banger, right? We're going to actually make a really cool game for assignment 2. All right, so that's it. Thank you all so much for tuning in, and I'll see you on the next lecture.